Wow, the pressure's on.
Very friendly audience.
Very friendly. Well, good afternoon. My name is Jim Howard. I'm the Director of DevOps as part of the Information Technology and Communication Services at the Naval Postgraduate School. I'm relatively new to DevOps and to ITACs at NPS, although not new at NPS. I have the unique opportunity, having been a former Army officer for 30 years, I actually graduated from NPS as a student, so I can come at things in ITACs from a student perspective. In addition, when I retired from the Army, I came to work at NPS as a faculty member. So I have three different perspectives. Former student, former Army guy, and Army and Navy don't speak the same language all the time, but also a former faculty member. So I can look at it from the perspective of, what the hell is IT doing to us? That being said, when I came to ITACs, one of the first things I was impressed with was the use of industry representatives and industry experts to help us find solutions to our problems. And in that, we partnered with Vmware and Brocade to help us build a virtual cyber lab to support the Center for Cyber Warfare in a project that they had to start teaching naval officers the basics of cybersecurity and cyber warfare. So with that, I'm going to turn it over to Brian Recor and Eben Rodriguez from VMware and Brocade, respectively, to talk about how they supported us and assisted us and continue to support and assist us running and building the virtual cyber lab.
Cool. Thank you. So this is the session on new threats, approaches in modern data centers. And I've been at NPS about a year. My name's Eben. That's Brian, so you don't get confused. And I was pretty excited to work there because they, like Joe said earlier, they're looking at innovation and how to use the infrastructure of NPS, of the school, to foster innovation. But at the same time, you have some unique requirements in security coming from the Navy and the federal government that require some different controls. So how do you balance those two? And this is an exciting project that we were able to work on. There's a couple things I wanted to highlight that drew me to NPS. One of them is it is a school, and they have a spirit of innovation and openness, and so they're starting to do things like this Hack the Sky conferences, where they'll invite people from all over the country to go either San Francisco, Austin, Texas, other areas, and collaborate with the Navy. And they're starting to work with the DIUX branch of the Pentagon as well. So there's a lot of excitement, innovation, and hacking types of ideas. And this last project they did had 2 swarms of drones. So NPS brought 50 drones, and they partnered with Georgia Tech University, and they met out here in California in a big field and had the drones using artificial intelligence algorithms and servers in the back end. The drones were programmed to fight each other, dogfighting. And so they're taking what they learned from those types of experiments and making the world a safer place. So there's that partnership with academia, not just military. So like Jim said, this talk we're going to explain about the specific lab that we built. It's a VMware-based lab that runs for the Center of Cyber Warfare. And it's pretty exciting. When I got here, there was some history behind this lab, and they had a number of iterations or generations of the design. Throughout all, it was VMware and pizza box servers. They had different amounts of memory, storage, and whatnot. There were actual 2 racks of equipment that were there, and they kind of borrowed some and bought some and put it all together. And they were able to prove the concept that this could be a viable education tool for teaching cybersecurity concepts. When you're doing the cybersecurity training or education and research, they're actually downloading malware and viruses and things that you wouldn't want on your network into these little sandboxes and testing them. And the engineers, the students get to figure out how the hackers work and how the malware was built and how it changes over time. And they can study that in a safe environment that is protected from the rest of the network. It's isolated. And the way you access it, if you ever use VMware View, is there's a program that you run that allows you to connect from your laptop or device to a virtual desktop environment. So we've opened that up and made that available. There's students all over the world. I think we have students in Germany, country of Georgia, other governments that we work with that have their students take classes in these labs with without having to come here to this country. So it's a great sort of distance learning environment. Let's see. Like I said, they're studying the malware, so there's chances for human error. If they, you could say, well, why don't they use their laptop or something? They could always do something wrong, make mistakes, configure something wrong. This way, we provide a centralized IT service that has the policy built into the fabric of the infrastructure. And Brian will talk more about the actual design. Some of the challenges that we were looking at had to do with the original design. So there were some, I won't call them misconceptions, but over time as technology improves, you have an opportunity to revisit certain design decisions and do things differently now. And this is a great opportunity where we've been able to look at what was done in the past, provide the same capabilities with new tools and new technology in a much more efficient package, more reliable, and easier to maintain. So some examples are in the 2 racks of equipment, we had a dedicated box that was just there for the Active Directory environment. For the students, we have hundreds of students using this from all over the world. We didn't want to give them necessarily full-on NPS email accounts and credentials and have to deal with all that. So we just gave them a separate identity in this cyber research lab. And so the professors we'd get a spreadsheet of who was going to be taking the class, and then we'd provision accounts for those guys and email them their passwords and make sure they could get in. So that Active Directory domain is just like an enterprise domain, and we have to maintain that. And so there was dedicated servers just for that. We also wanted to make sure that the uptime could survive a hard drive failure, power supply failure, and not have any single points of failure. To do that, we'd set up 2 of the security servers from VMware, and you could load balance between them. So now we need a load balancer. Well, guess what? That was a big physical box, probably cost about $100,000, and took up this much rack space for the load balancer. And so we were able to get rid of that and replace all these old systems with new equivalent systems that had much better capabilities. So we'll talk about benefits, but at a high level, this was demanded by the professors. If we didn't provide this resource for them, they would try to go elsewhere or try to do it themselves. So we're trying to provide that environment for innovation. And they've been able to increase the amount of students and the usage on these and to come up with new use cases as well. So I'm going to turn it over to Brian so we can talk about how we did it.
Yeah, and how Eben was, just talking about a little bit here, we had to pull in a lot of these services into this cyber lab, into the virtual environment, pointing out that we went from 2 racks down to 2U. Now we're virtualizing everything within the environments, and we had to bring those services into that virtual environment. So by doing that, we're virtualizing more and more of the environment, which increases more and more of the east-west traffic, the traffic that's happening internally there. And this is a VDI slide that shows you all the users within that, all the users that connected into this this lab, this 2U environment. I think at the moment is housing, I think, probably 5 classes, potentially 6 at the time. So you multiply that out by the number of users. It expands the amount of east-west traffic that's going in, and things that we have to take into consideration. I first want to focus on the security portion of this, and then kind of talk a little bit more about some of the services that we brought into the cyber lab. So as most of this traffic is east-west in the environment, just the VMs essentially talking to each other, we had to take more than just the perimeter approach, right? Because we know that perimeter is just not enough, right? It is important, and we do leverage that. And that perimeter security is that Palo Alto firewall that we have on the outside. But just as a Star Wars analogy here, one point that gets inside, it could start a chain reaction throughout the entire environment, as you've probably seen throughout the week. And the traditional security approaches, is just not enough. The traditional security approaches, it's that hard outer shell. The inside is real soft, and we wanted to go to more of a zero trust type of model within this, as opposed to more just trust and verify, or trust but verify afterwards. So we had to take into consideration the different trade-offs between security today, with the different approaches, the trade-offs that we have within security being context versus isolation. Where a traditional approach says that there's two different ways, that we approach this. One, from the bottom is from the perimeter, where we have high isolation and then low context, right? We can isolate down to the IPs, to the ports and stuff, but we don't really know who is doing what and what applications are doing those things, right? And then the other approach to complement that you take is put something in the guest. And we have to do that at NPS. We use HBSS, McAfee tools, and some additional Symantec tools. But they sit inside the guest, and they have high context. They know actually who those users are and what applications are going on, but there's low isolation because they actually sit in the same user space as the operating system. If a potential attacker gets in there, they can disable those. Sometimes the users themselves can try and manipulate them in some fashion, and then there's no ubiquitous enforcement between the two. So we had to take that and try and get to the holy grail of this compromise, where what ideally would be putting in a physical firewall in front of every single machine throughout the environment, which we can't do, right? This is a virtual cyber lab, and you can't even do this in your physical environment because, one, it's too costly and it's too hard to manage within the environment. So we leverage the software-defined data center. As we said, this whole thing is virtualized in a 2U type of environment to where we can leverage security right within the hypervisor. We can get the high context because the technology is able to see inside the guest and the things that are happening, the services that are running, the users that are going on. High isolation because we can provide the same type of protection as a perimeter, because we can protect outside the virtual machine from every user that's there. And then we can manage it all through one central management point within VMware. So we leveraged some of this term called micro segmentation that's given to us by NSX, which is VMware's network and security tool. First is isolation, right? We were able to configure virtual networks within the environment to provide native isolation. So these classrooms have sometimes same IP addresses within them, same subnets, but they're so isolated that we're able to, they're not able to even know about each other. Then we're able to segment the different type portions within the particular classrooms to where there's user networks, there's say server networks, there's one particular experiment networks that they're working on for that particular class, and then leverage some advanced services as far as firewalling capabilities that occur within the hypervisors, and then extend that in to potential partnerships with the Palo Alto. And then, so we're able to take this more from the traditional network-centric approach to security to more of a mission-centric type of approach, to where traditional security says we're going to architect the network in such a way where we have a bunch of VLANs and we're going to try and force everything through a firewall. And you see on the left-hand side. And where we want to move to more of a logical type of separation between these, to where we can have each classroom has their environment set up, and then we can create logical security groups within there and provide different policies throughout, for particular users as needed, what's going on there. And then provide, through the hypervisor, able to provide a firewall set rules, policy that go around every single virtual machine, right? It's not just one firewall that they're all trying to run through, one physical firewall. It's essentially a firewall that's, for lack of better terms, shrink wraps that VM now, and everything is managed individually, or it's managed through Virtual Center but they're treated as individual firewalls there. And one thing I like to note is part of the DoD is they're recommending. They're already recommending this concept of compartmentalization and segmentation. And the nature of DoD is recommendations eventually become policy. We saw this with virtualization, that they first recommended it, and now it's become policy that you try and do virtual first. So this shift is begun, and we want to take that into account for the Cyber Lab. So leveraging NSX, it gives us a security platform that runs within the environment, as you see on the left-hand side. It provides a set of services that are occurring or that is native to VMware, and then we're able to leverage best-of-breed services from Palo Alto and such. So the native firewall capabilities within the NSX technology is through layer 4, where there's some circumstances that we need to have higher advanced next generation firewall capabilities, and that's where we redirect and leverage the security platform to extend into the Palo Alto device, and we're currently actually looking at from a future aspect to leverage virtual Palo Alto firewalls to extend that capability. So as we look at the topology and how things are laying out, this is a very representative diagram of the Cyber Lab. It's relatively, we want to keep it relatively generic and such, but this is one of the diagrams that Eben and I first started going over when we started talking about the design. And this thing started, we had the existing one. I worked some on the existing or the previous 1.0 version, as did Eben. And then when this one came to, there were a lot of different requirements. One being security, first and foremost. Two was the different network services. How can we leverage routing capabilities, DHCP capabilities, load balancing capabilities, all of these things. We drawing up on the whiteboard. They had a room that has as many whiteboards as monitors behind me, and we drew all over this. And we see how, if we go from the bottom, each one of these individual classrooms has virtual networks with logical routers between them. So the routing is occurring in the hypervisor. The traffic is never leaving this 2U physical box, right? So each one of these is a classroom. You can see there's separate networks that are illustrated here, and down below. Can't walk away from the mic. And so the different logical networks there. One of those networks would be a user network as well, and so the user network would then the student would come in and they would land on a particular network with their VDI session, and then they would land in their corresponding class, and they would be able to provide the different functions or whatever the instructor is setting up for them. Everything in this particular block is logical in a sense, so we can spin up the particular VMs that the instructors need. We can spin up the virtual machines that the users are going to connect to. We can have virtual routers that need to provide the connectivity. The different firewall capabilities, all virtual. So one of the benefits behind this was we're able to take this and easily one, snapshot this if we need to, or two, reprovision this class going forward to make that new provisioning process of classes much faster, where before they had to take a lot of time, a lot of planning, and do it at certain times within the school year. We provided a lot more flexibility from this aspect. And as we go up, we're leveraging still virtual technologies of virtual routers, or this edge device is what it technically is called, is more of like a Swiss Army knife, so where it's providing logical load balancing in here, right? It's providing additional firewalling capabilities in here. So all of this still is it's still virtual. It comes up to an aggregation layer. because we're having different five, 6 classes at this point, we planned for scalability as we went forward. We even architected this design, if we wanted to add more and we needed to add more physical resources to it, we could easily just add more underlying physical resources and extend this capability. All of this is abstracted from the physical environment, and that's one of the beauties of it, that it's all the connectivity, the security, everything is contained within that realm. So then we were able to solve a lot of those problems, but then there's still things that we needed to do going forward, and we have plans to go forward with this. And Eben and I will probably tag team this section, but one of the things that we wanted to do is automate. The more we can automate, the better. And some of the different aspects that we are looking at is the Brocade workflow composer that we have a slide on, and then also leveraging some type of CMP, a cloud management platform. VMware has their different tools, and then there's also OpenStack that's looking at for different projects within MPS. But we could leverage, in this environment, we could even leverage OpenStack on VMware, which could easily just plug into this. And this cloud management platform will just automate a lot of the provisioning process of the whole overall system. We had to take into account too, planning to integrate physical systems. Even did show some great examples. Hack the Sky and these swarm things, and then there's you never know when a professor is going to come and say, I have this requirement, I got to connect these different devices to this environment. We have to plan for that, right? So one, we're either going to plan for some type of routing, communication that we can just route those things, because hopefully they all speak IP. And if not, if they have to talk, on the same broadcast domain, we can leverage some type of hardware bridge where we can leverage or bridge the technologies from VXLAN to VLAN and leverage that through Brocade technologies on the switches. And then lastly, where it did talk about the integration between NSX and Palo Alto. And this is going to be probably one of the ones that is easily tackled because it is virtual, right? We can tackle that one first. And then in the previous session, you see Joe and Bob talked about the cloud, leveraging Amazon. We're looking at ways that we could even extend this Cyber Lab into Amazon and leveraging the technology, this NSX network technology, to extend that to where now these networks not only live locally, but they can live in the cloud. The security policies around those VMs that I talked about not only live locally, but they also live in the cloud, and we can move those back and forth seamlessly. So we can dive into each one of these. If you want to talk about this one, and then we can kind of go into detail.
Yeah, so it's important to note that Brian and I are just consultants there working on site, helping the existing IT team. And there's 2 people that have pretty much built this environment and managed it, Edgar and Eldor. And we've shown them how to do everything. We've helped them through getting it all set up and doing some upgrades and whatnot. But they're the ones that do they used to support the old environment. They helped the professor bring it over from the old building where he had set it up years ago. And then they brought it into the IT group and have gone through all these upgrades. And they have, in the past, everybody's been doing all this stuff by hand. Every time you set up a new class, they had to run a script, type a script, and do it by hand. And then they'd set up a new class, so they'd tear down the old one and build new ones. And that's all manual effort. And so there's these tools now that are basically workflow automation tools where you program them to do the work for you. And then if you want to do it again, you just push a little button. And it might ask you some questions like, how many computers in the class? 1 Windows and 2 Linux computers for each student and 50 students. Okay, boom, boom, boom. Push the button, bam, it makes it for you. Do you want them to have IPv6 and IPv4? Yeah, okay, let's do that too. I'll build out the DHCP servers. So whatever it is, how much disk space they have, all those parameters can be programmed in. And then there's these modules that can be added in to allow it to actually, you can either have humans drive those actions, or we can automate them with sensors. So that would be useful in the case of a cybersecurity attack. We might see some malicious traffic, and that could trigger an action to send an email to somebody to take a look or to automatically implement a firewall rule or something like that. So that's StackStorm. It's an open source tool that we're starting to look at using now. So.
And then this one is, leveraging the CMP. We thought OpenStack might be the best because it's what they're already leveraging or looking to leverage in other projects within NPS. So we can leverage this VIO, which just would live. It's just a set of VMs that lives on top of the current hypervisor. So they don't have to stand up a new KVM hypervisor below it. It can just live within this environment, and then it would be able to extend that automation, from the physical physical world, we'll say, or physical underlay type of environment, and extend that into the virtual or overlay type of environment, to where now we can deploy this classroom, as I said before, with all the different components: networking, security, compute resources, everything that needs to be done for that particular class. And we can have, possibly a portal that we can go through to do this and templatize these things as we go forward there. Build this out. Yeah, and it has all the different components down below. This one is a slide, for the Palo Alto integration, to where we can leverage that. As one of the technologies I kind of glossed over was the firewalling capabilities in the hypervisor. It's called a distributed firewall, occurring in the hypervisor, and up through layer 4 technology, stateful firewalls, which is good for a lot of things, but we want to extend that capability to the next generation firewall capabilities that Palo Alto has, and kind of bridge that relationship that already exists within the environment and exists from the physical side. We want to bring in a virtual firewall into this environment that would live on the physical host and integrate with the NSX technology through sets of APIs, and extend the visibility, the protection around the overall environment.
So I want to give an example of where that's going to be useful. Is right now we have student machines that are their Windows machines that they VDI into and connect to do their research. They might open Microsoft Word and take notes or use some tools. And then they have Linux machines. That's where we put the malware and do the actual attacks. And those are in different networks. So the current firewall that's built into NSX is kind of layer 4 compatible, and it says allow basic traffic on these machines or those machines. But with the Palo Alto, using app ID and user ID, we could say, hey, this person who's logged in, we know that's a professor or an assistant to the professor, and he has the ability to have kind of super user powers. So he'll be able to go do extra stuff. He can delete files or something. But the students might have more limited privileges. And so that's where one of the advantages that we're looking to the Palo Alto for.
Mm-hmm. And then this slide is kind of a vision that Eben and I had discussed and talked about, leveraging AWS and potentially extending the Cyber Lab into the cloud. A lot of possibilities there. Recently, VMware announced a partnership with AWS, it's essentially running the VMware hypervisors in the AWS environment. And AWS still manages and does the underlying infrastructure, but now the team can manage this overall environment, through vCenter, the tools that they use to manage the environment, and they can see their on-prem data center, and they can see their data center in the cloud through the same UI, same user interface, and be able to do live migrations between these, be able to extend the network capabilities and security capabilities between these. This technology, I think it's going to add a lot of capabilities to the infrastructure, and a lot of flexibility to be able to move back and forth. This is something that is currently in beta. I know NPS has talked to VMware as well, in current talks with Amazon about this. And this is just a tech preview right now, but it's probably something that'll go live towards the end of the year, and it's something that's on the top of our minds as we look to extend these capabilities. And then this is the last
Yeah,
one.
so this is a design we got from Amazon. We got permission to share this with you guys. It's a program, an architecture, a design that they've done with Jim, correct me if I'm wrong, Navy ROTC?
It's Navy ROTC. Right now they're building a pilot to run this summer for 6 universities, approximately 105 Navy ROTC students, to use this cyber lab built virtually
In the cloud.
AWS cloud, with the hopes that eventually it becomes available to all Navy ROTC students, so thousands of students across the country.
So I'll repeat that for the people on the stream. I'll summarize it. Thousands of students will be able to use this design in the future. We have a pilot program going on right now with the Navy and the ROTC programs in various universities. So we're looking at designs like this, and the whole spirit of CENIC and what we're doing at NPS is about collaboration. And so we're really looking at other institutions and either learning from them or helping them with what we've learned and sharing these designs. And the cloud is a great example of an environment where we can take a design that a professor started years ago with his students and his ideas and expand that now to others and share that.
And that's
So, quick
Yeah.
question relative to that. Was that
Let's get the mic.
yeah, relative to the sharing of the resource with the ROTC students, that was just at the college level and not necessarily the JROTC at the high school level?
That's correct.
Right.
Okay, so, okay. Yeah, because I know that, I mentioned the other thing that I volunteered for Cyber Patriot, and a lot of these high school students that are trying to do these functions have limited compute processing power, and they would benefit from some shared resource like that as well.
Yeah, so this is actually a fairly common Amazon blueprint, and we've just adapted it for the type of training that we're doing. So they have the concept of VPCs, virtual private environments, and we put them in multiple availability zones. So I don't know if you guys ever, last month there was a big outage. Everybody was crying because one of the Amazon sites went down. So I want to be able to survive that type of outage.
Eben, I have a question.
Sure.
You mentioned recently about templatizing the courses. Can you talk about how that might happen in AWS with something like CloudFormation?
Yeah, exactly. So Amazon has a technology called Cloud Formations that you could either download existing ones that are already built, or you could give a design like this where maybe a professor, and a lot of, you've heard of shadow IT, so a lot of these projects didn't go to IT first and they're like, hey, I need you to help me build this, right? They're like, I've just spent the last year building this and I want you to help me support it. So what do we do now, right? So they came up with the great idea, they built it out, and that's what the cloud's really good for. You can start small and grow, but then you get into deep water because now you're like, I don't want to wake up in the middle of the night and fix it when somebody needs it because something broke. So what Chris is talking about is we can take an existing design and actually run a command to dump a description file out of it called Cloud Formations. And then we can see all of the details in code about that design. And that code could be used, you could actually delete the old environment and run this code and it'll rebuild it exactly the way it was. Or you can modify certain aspects and change the size and change the parameters and run it again in a new environment. And then that's how you're able to take one side, copy it, and clone it somewhere else. So that's one of the things. And one of the great things about that code is we can store that code in our source code repository and have a security team review it and notice, oh, your firewall's letting in these ports that we don't want, or we need to tweak some of the firewall rules or whatnot. So every aspect of the environment is documented there.
yeah.
Yeah, oh yeah, they could be shared if you want. It's in your account, and then there's a huge security engine behind it as to how you would give people access to it if you want to make it public or private and groups and whatnot.
That's a great segue. I mean, we're onto the question section.
I had another slide, something about I think it might have been the notes. There's some web resources. You remember
I didn't add that.
for the NSX code sharing where we share examples and blueprints. Was the blog?
I didn't add that.
No? Okay. You can just Google it, NSX templates, And we'd be happy to share these designs. Right now, they are kind of private to our environment. We haven't sanitized them other than what you see here, and done a lot of talking about it.
So I guess any questions on any of the technologies, why we chose what we did? I know the NPS team was largely the ones that were making these decisions, but Eben and I were involved in almost all of those discussions. But any questions on any of that stuff?
Have you done penetration testing on the...
Okay, I'll repeat the questions. Have we done pen testing? No. So we know that they're downloading malware into this environment and running it, and it's the professors. We designed the rules to be very tight, so the pen testing is not really necessary. It's not a first of all, I don't think we do pen testing in some of the research environments where we know it's like a sandbox and they're going to be breaking things. If anything wrong happened here, we would just delete it and recreate it.
And this is a sandbox type of environment when you think about it, because it does live out on a secure environment. It can't touch the actual production environment of MPS because of the nature of the things that it does.
We got 2 more questions.
Yeah. I heard there are ways to escape from the virtual environment to get down to the, what's your mechanism to protect that?
That's called science fiction. No, every software product has defects in it, and if there was a mistake made by an engineer somewhere, it could have a defect, and that's called a vulnerability, and then someone has to be able to compromise that vulnerability. So there are a couple of VM escape examples that you'll find here and there, but they are very quickly patched. You'll get a CVE assigned to that, and then VMware issues a patch.
And I work there, so take it for what it's worth. But there hasn't been any documented VM escapes. Any of those that have been exploited, there's been things in the past. You may have heard of like Blue Pill, things like that are more of theory, but none of them have been documented in any production environments. As where most people are standardizing on this.
And I will say a word about virtualization and cloud security, that there are a number of best practices that many organizations don't follow. So one example is we're building all these new servers. They should have the SSL certificates put on them from your organization. Don't just use the one that comes out of the box, right? Change the passwords, connect to Active Directory, all these things. So if you don't, there's a shift in the vendor space from having things be easy to use out of the box to having things be secure out of the box. So if you've installed an Ubuntu operating system lately, SSH is not even enabled on it. You have to manually go in there and turn it on. So that's a shift in thinking that the vendors are having. So some of the escape features you hear from VMware or on the workstation products where they had an attempt to make it easy to use. So the copy and paste clipboard function where you can copy from a VM to your desktop. We'll make it easy to use, so we enable that by default.
And you have to trust the host at that point, the underlying.
But now it's vulnerable to attack there. So check the settings of your environment. Go ahead.
With regard to your NSX Micro Segmentation implementation, how far along are you in the process of actually locking it down and getting out of a monitoring or an audit mode and being comfortable in having the actual micro segmentation fully
so
deployed?
that's baked into the NSX design that we implemented back in February, March last year, was the redesign. So the previous design relied on VLANs to not do micro segmentation, but there were 3 VLANs, 1 for each class, right? So the professor wanted another class, he'd have to file an IT ticket, and some IT guy would have to make the VLANs, trunk it through all the switches, and the VMware guy would connect it into the VMware environment, then they could make the classes. So with the new environment, we have a big OSPF network that's trunked in there, and that OSPF terminates in the NSX edge routers that are all virtual. And now the server management team that creates the classes does not have to contact the NOC team, the network team anymore, to create VLANs for each class. So now it's up to the server management people writing those scripts. Say I want 5 classrooms, 10 classrooms, however many. And what they couldn't do before that they're able to do now very easily is, I want this classroom to have 5 networks on it. 10 networks, 100, 1,000 networks. They can just do that through code because these virtual networks are not VLANs anymore. They're VXLAN technology. And so VXLAN has a tenant ID associated with it.
But what about the actual firewall policy?
Yeah, to extend on that, it's probably not as tight as it could be at the moment. We have projects in place to monitor all the different traffics and stuff. There are some generic loose policies from a microsegmentation standpoint. You know, like the Linux, what is it? The malware network will say that they're working with has more restrictions on it to where it can't really go out. You know, that communication can't go out. The users' desktops, you know, have restrictions on it to where they're not able to talk to each other, right? Because that's something. I mean, that's an easy one to where we know for a fact that that's something that we can put in place today.
You could give a class on NSX firewall rules. There's all these parameters that you can use to create these firewall rules. It's not just IP address, source, and destination anymore. We were looking at, so what you can't see, it's kind of small, but I think the blue ones were the Windows machines, and then the other ones are like the Linux machines. So we could say like a example server and example client with malware, and then the Windows machines the students use are for the administration of the lab environment.
Yeah, it's I guess you could say they're fairly generic at this point because us as include us in the IT staff. There's things that we know for a fact that we can put in this environment without disrupting the professors and the students' work. And it's something that we had to balance. You know, how much do we go? Because we could easily lock this down, like you probably would in more of a production environment. Like just regular production, but since this is a classroom research, they're not probably as tight as you may see in some other places.
So an example might be a professor wants to allow port 22 from the Windows machines to Linux machines, but inside the Linux, and we're identifying by machine name, so have like a class code and then W for Windows and L for Linux. So the firewall rule could say if the machine name ends in L, it's a Linux machine, and have these rules. And we can also have different firewall rules for different classes based on the machine name that way.
Yeah, and if I might add, that enforcement point from a microsegmentation standpoint, you might know. I mean, it is a great question. So that's why I say you might know. That enforcement point is here. So that's being done around every single VM. So it's being enforced before it even touches the distributed switch, the virtual switch that it's connecting to. Traditional security would say, hey, let's put it somewhere up here, right, and put those rules in place. But we're actually putting rules down at every single one. So we can, like I said, they are fairly generic, but we can get specific down into possibly the instructors have different sets of rules as the students do. So that's something we can leverage through integrating with Active Directory.
So I'm going to ask the last question, exercising my prerogative as moderator. What are the traffic flows, network traffic flows that you're seeing in and out of the external network? So are you monitoring that? Can you know? And then a corollary question is, what are the sort of the minimum system requirements on the client side, network-wise, for being able to connect and interact in real time?
The view for the students.
Yeah.
Yeah. So I'll give you the basic answer, and then Brian can give you more details if you want. From a student perspective, the Horizon View client can be installed on an iPad, a phone, a laptop. It's just a little agent, and that connects over either port 443 or PCOIP ports, depending on the amount of performance and latency you want. It would even have the ability to, if I was using my laptop here to connect to the CyberLab, I could plug in a USB device in my laptop and it would show up on the VM over there. So those are all supported through the VMware technology. And that's all we allow from the internet into this lab environment, because everything else is self-contained in these 4 servers.
Right, I understand. Yes, so I guess from a traffic flow perspective, we allow the users to connect to their virtual desktop environment. Once they land in this environment, we try and we limit that traffic to where it stays within their virtual I guess, little sandbox there. It doesn't communicate out to the network. There's some of these networks we're not even advertising as routes to go out, so they don't even know how to talk back out to the.
It'd be on the order of like Netflix streaming or something like that, just because you're just streaming the desktop.
Yeah,
Exactly.
There's all these charts depending on the size of the screen that you want to give the student's desktop. You know, if it's 1080 by whatever VGA, it's much less bandwidth. If it's a 4K screen, then it's going to be more bandwidth.
Exactly, and they're streaming their desktop, so that data is never leaving the data center, right? It's staying within this environment, and it doesn't matter if they're in a classroom or if they're connecting from the wireless, on a bench outside, or if they're connecting, if they're even get deployed and they're across the world, they can still connect to it and do the work that they need to do.
So one interesting challenge we had to answer about the segmentation question before was these Windows machines do have access to the internet. So imagine the student's coming and want to take a class. He's following the instructions that his professor gave him, to kind of get started on the lab. And it says, open your web browser, connect to this website, and download this malware. Right?
Lesson number one.
Right. And so that's why we have a specific OSPF network that we can identify in the perimeter firewall to allow them to do that type of thing. All right. Well, since that was the last question, I guess we'll end it. But we're around if you have any other questions.